Okay, so the problem says an aircraft is flying horizontally, right? So this way, at a constant height of 4,000 feet. So that's this 4,000 feet that we have here, above a fixed observation point. So that's our little person right here. At a certain instant, the angle of elevation is 30 degrees and decreasing. And the speed of the aircraft is 300 miles per hour. Okay, so let me write that down. So at a certain instant, the angle is 30 degrees, and the speed of the aircraft is 300 miles an hour. Okay, so I'm going to, so we talked about this last time, right? This is going to be a derivative. And so I'm going to let you guys tell me what that is. So this is like a fill in the blank. So what is that derivative, that 300 miles an hour? That's going to be the derivative of... Well, okay, so this is t right here, right? So that one's easy, but what letter am I going to put on top? So I've heard A, I've heard Y, I've heard X. Anybody have a D? Okay, so the answer is it depends, right? Because, so what does that 300 miles an hour represent? So it represents the plane flying horizontally, right? So before I label the rate, what should I label before that? I need to label the unknown. Right, the value that's changing, right? The value that the fact that the plane is flying this way, what is that? What value is that changing directly? Well, it's changing the angle, but that's more indirect. This right here, right? This distance down here, the horizontal distance, right? From the person to the plane. Does that make sense? So you need to give that a letter so that then you can label the derivative, right? Okay, so that's why it depends. So you can label it whatever you want. What do you guys want to label it? Y. Okay, trying to go different on us. That's okay. So then this would be dy over dt, right? So those two match up, right? The quantity that is actually changing at this rate, 300 miles an hour, is y, and then it's changing at a rate of 300 miles an hour. Okay, so now, so that's good. Now the question, so there's two questions actually. The first one is how fast is theta decreasing at this instant? And then it says in degrees per second. Okay, all right. So what should we do with that business there? Any ideas? We need to translate the question into math, right? Basically. So what's the question? The question that we need to answer here. But we're not looking for theta itself. We're looking for, what is the question asking for? The change, right? So the derivative of theta with respect to t, right? That's what we're looking for. When theta equals 30 degrees, right? And dy over dt equals to 300. Meaning the instant that they gave us above, right? Does that make sense? Okay, so any questions up to this point? Just the statement of the question itself. We're doing good? All right, so we've got the first step down, right? Yes. You have a question, Sage?
Oh yeah. So can you just quick explain your thought process on A, deciding the derivative of theta, because that's the.
Yeah, because that's the question. So it says how fast. So this is a derivative, right?
Right.
Okay. How fast what is it asking you for? It's asking you for theta, right? So how fast is theta decreasing? So in other words, at what rate is theta changing? Or what's the derivative of theta, right? So all those are pretty much interchangeable. You want to, rate, derivative, it's like an immediate connection, right? You see rate or how fast, that's a derivative, right? Okay, so any other questions? Probably. Oh. Okay, all right. So now what's the next step? So that was the first step, right? Draw the picture, label, and then write down the question. What's the second step? Formula relates to our info, right? Okay, so now this time though, so we've got theta, right? So theta is important. We have y, which we don't really know, but we know we have a rate on y, right? And then we're given an angle theta. So how many options do I have here? Well, first of all, does the Pythagorean theorem even come into consideration? No, right? Because the Pythagorean theorem does not include an angle, so we don't even think about it. So what should we think about? Trig functions, right? So we can think of sine theta, for example. Sine theta would be 4,000 over what? It's opposite over hypotenuse, right? What's the hypotenuse? We don't know, so what should we label it? Wowzers, you guys are really going off the rails there. X for the hypotenuse. First Y for the horizontal distance, then X for the hypotenuse. Okay, let's just call it big D for distance. Okay, so 4,000 over D, right? Which we know nothing about, yes? But we at least know that it's changing, right? It's not constant. Okay, that's one option. We also can do cosine instead. What would that be? Y over D, right? And then, what's another option? Tangent, yep. Tangent is 4,000 over Y. Okay, so now notice we have a decision to make. So, and it matters which one we pick because if we pick the wrong one, it could be that best case, we give ourselves a whole lot of extra work. Worst case, we can't actually solve it. So what should we do? So what you want to do is you want to look at the information you're given and the information that you're being asked about and try to use the one that has that information, what you're looking for and what you have. So notice they all have theta, right? So they all have theta, so they're all good there. But notice I'm given a rate about y here, and I have no information about d, right? Nothing. So should I use sine, for example? No. I should not use sine because I don't know d. Now I could find d, but what would it look like if I found what d equaled? I would have to use the Pythagorean theorem, right? To find d, that means I would have a square root in there. So same thing with cosine, right? That one even looks worse because you have a y and a d, and you don't know what d is, so you'd have to find d. Okay, so which one wins? Tangent wins, right? Tangent wins because it has a constant, so constants are easy to get the derivative of. And then you have y, which you know the rate at which y is changing. So that's good, right? You with me? Okay. All right, so that's how we make the decision there. So let's use that. So if I do tangent theta is 4,000 over y. Okay, so what would I do at this point? What's the next step? Derivative of both sides, right? With respect to what? T, right? Always t. And what's the derivative of tangent theta with respect to t? Okay. Times d theta over dt, exactly. Because theta is a function of t, right? Theta changes with t. Okay, and then what is this equal to? So 4,000 over y, when you get the derivative of that, remember you think of it as 4,000 y to the minus 1, right? So you do the power rule. So what would you end up with? You would end up with minus 4,000, right? Y to the negative 2, right? But we don't like negative exponents, so I'm gonna just move it down as y squared. Is that okay to do? Times, exactly, dy over dt. You guys okay with that? That I put y squared on the bottom instead of y to the minus 2 on top? Is that okay? So now what? Now we need to find all the stuff, right? Yes, good.
Why is it theta on the secant side and then on the other side dy d theta left over d?
Well, you have to remember where those come from. So, let's see here. Let me see. Okay. When I have tangent of theta, theta is actually a function of t, right? So if I get the derivative of tangent of theta, what rule do I have to use? I have to use the chain rule because I'm getting the derivative of tangent of theta, but theta is a function of t, right? So then you get the derivative of tangent theta, which is secant squared, but then times the derivative of theta, which is d theta over dt, right? So then why is it that we end up with a dy over dt here? Well, because you get the derivative of y, and y is also a function of t. Right? Because both theta and t are changing as t changes. Does that make sense? Yeah? Okay, so good question. Oh, I don't know why I did that. Okay. So let's see here. All right, so now what do we do at this point? I plug in what I know, right? So I try to plug in all my stuff. So secant squared theta. So do I know what secant? Plug in 30, right? So we're given the angle. So we know the angle is 30. So, okay, well, we can do that, right? So secant of 30 degrees. Well, who works with degrees? Nonsense. So what is this? Secant pi over 6, right? And then let me write it like this. So secant of pi over 6, and then whatever we get from that, we'll square it. Yeah? Okay, so secant, remember, is 1 over cosine. Yes? Okay, and then cosine of pi over 6 is? So cosine of pi over 6 is? Root 3 over 2, okay. So it looks like you guys need to practice your trig. Root 3 over 2. So then secant of pi over 6 is the reciprocal, right? So 2 over root 3. If you square that, you get 4/3, right? So this is going to replace secant squared theta. Sound good? Yeah? Okay. All right. So I'm running out of space here. So I'm just going to erase that. And I'm going to replace this with a 4/3. Okay, now, what about d theta over dt? That's what the question is, right? So I don't worry about finding that right now. Let's see. And then minus 4,000 over y squared. What is y? Do I know what y is? Well, let me put what I do know. Oh my gosh. Okay. I know dy over dt is 300. Okay. So what is y? All right. Okay. So now we need to find y. Okay. So how do I find y? Solve for y. Yes. Good. Okay. Yeah, I need to use one of the trig functions, right? Because notice I haven't used this 4,000 yet, right? Yeah, so tangent of 30 degrees is 4,000 over y, right? So y is equal to what? 4,000 divided by tangent of 30. What is tangent of 30? 1/2 over. Okay, that we're doing better. Okay, 1/2 over root 3 over 2, which is the same as 1 over root 3, right? Okay, so y is root 3 times, well, actually, let's do 4,000 root 3. Okay, so that's what y equals, so we'll put that right here, 4,000 root 3. Okay, so that's it. That's all we need. Because then d theta, actually that isn't all we need. There's a bit of a wrinkle here so let me just move it over here. So d theta over dt is equal to, let's see. So let's try to simplify some stuff here. So this 4,000 cancels with one of these, right? But there's still one left. So is it okay if this 4/3 I multiply it as 3/4? It's going to be minus, right? Let's see here. And then I have times 300 on top, right? And then what am I going to have left over on the bottom? If one of the 4,000s cancels, but then I still have root 3 squared, so that's going to be 9 times 4,000, right? Okay, which last time I checked is 36,000. You guys with me or no?
I'm confused on the -3
I just multiply by the reciprocal of this one. This 4/3, right? Because I'm solving for d theta over dt. Okay, now, so we can simplify this, but I have a question. What are the units of this? These are radians per? So if I go back here, this is 300 what? Miles per hour, right? So when I finish this up, I'm going to end up with radians per hour. And what does the question ask me for? Degrees per second. Okay, so we need to do a conversion. All right, so what's going to be my conversion here? So let's see. Well, let's simplify this a little bit. So this is, if I multiply the 3 times the 3, I get 9, right? And then cancel 2 zeros, top and bottom. And then 360 with one of the 3's reduces to 1 and 120, right? See, now it erases. Okay, so then 3, actually, and then 120 and the 3 reduced to 1 and 40, right? So this is going to be minus 1 over 160. Okay, so that's kind of nice. 36,000. It's, yeah, so 4,000 times root 3. Oh, it's not 36,000. See? What is it? It's only 3. That is right. I don't know. I'm waiting for you guys to stop me from doing these shenanigans. Maybe you shouldn't trust me. No. Okay, so 12,000, right? Right, because this right here, 4,000 times root 3 squared is 12,000. Right? Okay, so anyways, let's see here. So how does that change things? Oh my gosh, look at that. Do you guys see that? What is happening? It's terrible. I don't know what's happening.
I think that step on the bottom.
I think I don't like this app anymore. I think I don't like this app anymore. Okay.
It doesn't look like you've been recording for a while anyways.
What is it? It's recording on the computer.
Before.
What is it? Yeah, this one? I know. This is a different one. It is recording, trust me. You'll see when you watch it at home. If you watch it at home. Okay, anyways. Alright, back to the problem at hand. Let's get back to business here. d theta over dt. So let's go back. Minus 3 over 4, which is 4/3, the reciprocal of 4/3, yes? Okay, times, so this 300, I'm just going to leave it there, 300. And then this is 12,000. Okay, alright, there we go. So now we do a little simplification here. Get rid of these zeros. 3 over 120 reduces to 1 and 40, right? So then we end up with minus 3 over 160. There we go. Minus 3 over 160 radians per hour. All right, now are we good? Okay, so now we need to convert it. So minus 3 over 160 radians per hour. So you guys remember how to do this, right? So you multiply by unit factor. So let's say you want to convert radians to degrees first. So what's the conversion? 180 degrees is pi radians, right? Okay. And then what's the conversion of, so hours to 1 hour is 3,600 seconds. Yep. All right. So then what does that equal to? Of course. This is our final answer. What is it? Does anybody have a calculator to punch it in? Yes. Yes, I'm sure it's right. No, I'm not sure of anything. 0.000298416 degrees per second. Does that sound reasonable? Did I do that right?
It should be negative, right? Negative. So the degrees -3 goes down, and it does have a negative.
Yeah, so, I mean, well, it is negative.
Asking for decreasing too, so that's right.
Right, exactly. So because it's asking you for decreasing, technically if you write it positive, so if you're saying it's decreasing at a positive rate, you're basically saying that it's negative. But it doesn't matter. Anyway. Explaining that probably will just confuse more. But it is negative because it's decreasing.